Rendering 2, part 2, we're going to talk about constant buffers. Here's our simple shader again, and to begin with, we'll notice that the input positions go right here. These are the positions that we sent up in the first place. Where did we get those? Presumably, the artist created them, and as I mentioned before, the artist created the positions in model space. So these are the model space vertices. What we need to do is transform the model space vertices into those normalized device space vertices. And in our simple shader, we just copied them over. We just said, oh, it's already in normalized device space. We're good to go. But for a model that we're actually going to move around, we will need a matrix to convert it from model space into normalized device space. How do we do that? Well, let's use a matrix to convert the input position into world position. So we got the model position here, goes in here. We're going to multiply times the model to world matrix, and that'll give us world position. So now we have the world position here in the output position, but what we want was normalized device space, so we'll need to multiply by another matrix. I'm calling this matrix the view proj matrix because that is the combination of the view or the world to view matrix and also the projection matrix, which is the view to the normalized device space. Okay, what are these matrices? What is this and why did I put a C? These are what we call constants. They are in what we call the constant buffers. And that's why I put a C on them. Just to remind you, it's not required in HLSL that it have a C. I put the C underscore just as a reminder to the reader that these are constants. They're in the constant buffer. What is a constant? Well, it means that it's going to be the same for all vertices that are running this shader, right? When we set up our shader to run, one of the things we'll set up is the constant buffer. And then we'll pass in a bunch of these VNs. So each vertex has a different position and a different color, but they all share these, quote, constants. Okay. Very similar to C++, HLSL allows us to pound include a file, like this one, in this case, constants.hLSL. And just like C++, that means during compilation, go and open that file, get the contents, and just paste the contents right here. And that's going to allow us to do things like share these declarations across many different HLSL files without having to duplicate them manually, which would cause all kinds of errors because we make a mistake in one of them or something. Okay, so that's what we'll do. Let's look at this constants.hLSL file. And we'll see in here we have that C model to world matrix that we were using in our shader, and also the C view proj matrix that we were using. If you look at these declarations, they look very much like a structure. But when we used them, we did not use them as a structure. We used them almost as if they were just like global variables or something. And that's a little weird bit of the syntax. But we bundle them into these C buffer types of structures, not so that we can reference them by a structure, but so that we can upload them from the CPU as a data block. What we're going to do is we're going to, on the CPU, create a matrix 4 and a vector 3. We're going to bundle those together, and then we're going to say, hey, GPU, here is a bundle of data that I want you to put on register B0. We're going to tell the GPU that buffer slot index 0 contains this bundle of data, and if I've done my job correctly, that bundle of data will map to this structure. And then I can just reference cviewproj. Anywhere I reference cviewproj in the HLSL, the compiler will know that what I'm saying is whatever's in register B0, use the first matrix 4 that you find there. And let's take a look at this other one. This is register B1 has my model to world. So why am I splitting these things up at all? Why not just pack them together? Well, in register B0, you can see that I've put all of the camera related data. And in register B1, I'm putting the per object data. So each object has its own model to world matrix. So I'll need to re-upload that register B1 every time I change objects. But register B0, that's only when I change the camera. So if I have a bunch of objects that are rendering with the same camera, I'll leave register B0 alone, and that can save me a lot of extra uploads that are not necessary.